Sticking with the theme of everyday objects that use a lot of physics in them, I want to explain how a microwave works, because it involves a lot of really quite complex physics that hopefully I'll be able to explain simply. So again, we need the basis of atoms are little Lego building blocks that build up everything, but inside them they're made of particles, so they're made of protons, neutrons and electrons. And all we need to think about for this video is electrons, which are little particles that whiz around the outside of the nucleus being made up of those protons and neutrons I mentioned, and generally just fly about really quickly. So a problem with when you're talking about things that are that small is they stop obeying the same laws as us, which is what quantum and classical physics are. So we, being really quite big things, we obey classical physics, which are, the way we understand everything, gravity and stuff like that. If we go up, we come down. That's classical physics. Whereas quantum physics is a set of rules that apply to things that are too small to take any real part in classical physics. So a fact of quantum mechanics that microwaves use in order to heat your food up and drinks up and things like that is that particles that are really, really small can only exist at certain energy levels. Now, what does that mean? In terms of our world, it would be, I can only exist in a few points of this room. So it's essentially the same as, I can only ever be here, here, or here. So in order to make electrons move within these different energy levels, you have to give them some energy, because you have what's called the ground state, and then you have different energy levels above that of increasing energy. And to get them to go up there, you've got to give them some. The difference between the classical world and the quantum world, though, is that to get them to go to an energy state, you have to give them the exact amount of energy they need to get to that state. If you give them too much or too little, they just won't absorb it and they won't move anywhere. So it's essentially like me saying, well, for me to walk over there, I'm kind of tired, but I need some energy. So I'll go over there, but only if you give me a Kit Kat. However, there is also another difference between the quantum and classical world, in that when you go from a higher energy level back to a lower energy level, say, I go from standing up over there to sitting down over here, I'm using less energy sitting over here. In the quantum world, you get back the energy you gave it to get it over there. So it's the same as you giving me a Kit Kat, I'll eat it, I'll walk over there, but as soon as I come back and sit down, I'll spit the Kit Kat back out. So what a microwave does is it uses the water that's in your food, and specifically uses the energy levels of water. Different compounds require different amounts of energy to get their electrons to go up levels, and they're very specific energy. So what a microwave does is it gives out the specific amount of energy to get water's electrons to move up to higher energy levels. And when it's at a higher energy levels, molecules vibrate more, they're all energetic. And that's what a temperature would be. You give something thermal energy, it does exactly the same thing, it just vibrates more. So if you give it energy in terms of just you shine some radiation at it, and it absorbs the radiation, then you've got something that ends up being more energetic, i.e. hotter. And electrons don't actually like being at the higher energy levels, so they do like to drop back down, and as we said, when they drop back down, they give back out the energy you gave them to get them up there in the first place, which you would notice by your food feels hot. You don't have to touch it, but you get hotness on your hands just by putting it near the food. That's it giving the radiation back out and your hands absorbing it. So essentially that's the idea of how a microwave works. You give it a bit of energy, it gets all hot, it starts to try to give it back out again, but you eat it before it gets cold. But the only real difference being that you have to give them a specific amount of energy as opposed to surplus energy. You can't give something that obeys quantum mechanics too much energy, it just won't take it. So that's how your everyday microwave works. Thank you for watching.